let's get started with the learning. So our first topic is set theory. So the first thing you have to ask is, what is set theory? Set theory is about collections of stuff. So mathematically, what does that mean? Well, suppose you wanted to talk about your toys. So let's say a kid has some toys. You've got a teddy bear, you got Legos, you got dolls, you got action figures, you got cars, you got Nintendo, and you've got interactive books. So that's your collection of toy stuff. So mathematically, how can we talk about this group of stuff? Well, we can put that all together and call it a set. So the set of Stevie's toys would be, and you write it out like this. So first of all, those curly brackets, that's what we use to indicate a set. And from now on, we no longer need to say teddy bear, Legos, dolls, blah, blah, blah. All we need to do is give the set a name. So we can call the set Stevie's Toys, but since we're mathematicians, we like to use as few letters as possible, so we're just going to call it S. So S equals teddy bear, Legos, the set of teddy bear, Legos, dolls, etc., etc. Question: does the rectify that? Does the order matter? Does the order in which you write stuff down matter? No, why not? Yeah, exactly. Order doesn't matter if you still have the same stuff. Little Jimmy lives next door. The toys he has are Xbox, crayons, trains, cars, skates, basketball, etc., etc. So, oops. Describe this using set notation. How could you write this down? Right. There you go. Yes. Just like that. Okay. So we know how to write down a set. So now let's start talking about how to reason about these sets, to say things about these sets. Are these sets the same? Or in other words, does S equal J? Nope. Now Janelle has toys also. And we can't call that J also, so let's call it L. She's got skates, basketball, Legos, cars, trains, Xbox, crayons. So let's compare S, J, and L, and what do you realize? There you go. And how do you write that down? There you go. Same stuff, same set, J equals L. What if Janelle buys a Barbie doll? Now is it true that L equals J? Nope. But now there is still a relationship between L and J. I'm sorry? Well, we can know. We've got a new L, so we've redefined L. So L is now, or maybe should I call it L1? Okay. So let's now say that L equals the Xbox, the crayons, blah blah blah, all that other stuff, and now also the Barbie. So now this is L. So what's now true about the toys that Janelle has and the toys that Jimmy has? Everything, sorry? Okay. Okay. So it's true that they're not equal, but there's another relationship that's true. Let me put it this way: is Janelle ever going to need to borrow a toy from Jimmy? No. Why not? Exactly. Every toy that Jimmy has, Janelle also has. That's the relationship. Does that make sense? Okay, so the only thing we need to now figure out is, how do we write that down? So, everything that so the way that we write this is to say J is contained in L. So everything that Jimmy has, Janelle also has, or the way that we say that in set notation is that J is contained in L. Another way to say that is that J is a subset of L. We'll talk more about subsets in a bit. Now, how can you check if one set is contained in another set, or if one set is a subset of another set? You have to check. In the case of Janelle and Jimmy, you have to go toy by toy. Every toy that Jimmy has an Xbox. Does Janelle have that? Yeah. Jimmy has crayons. Does Janelle have that? Yeah. Now so far I've been calling this stuff. It's not really called stuff. In math, it's called an element. Yeah, it's like a little C. Okay. All right. So now let's start talking about the relationship between the element, in this case the toys and the person, or to put it in math, the elements and the sets. Is Nintendo one of Stevie's toys? Okay, so just to remind you, Stevie's toys, yes. Okay, so Nintendo is one of Stevie's toys. How do we write that? Nintendo. I used N. Okay. Alright. So what did I just write? So Nintendo is one of Stevie's toys. The way you say that in math is N, and then you do this funny little E that says N is an element of S. Another way to say this that sounds a little less mathy is that n is included in S. Is Nintendo one of Jimmy's toys? Nope. So how do we write that? Boom. Just put a slash through it. And of course that should be a J. Now, what is F, the set of all fun toys? Can you tell me? The set of all fun toys. Sorry? It's a what? Well, how do we say what a set is? With the brackets and well, that's the notation. What do we have to write down? You have to. I'm sorry. Well, that's naming the set. How do we say what the set is? You make a list. So can you make a list of all the fun toys? Well, you can, and you can. Are your lists going to be the same? Probably not. So can we define the set F, the set of all fun toys? No. This is not a well-defined thing. We can make a list of what Jimmy's toys are, because Jimmy either has a toy or he doesn't have it, and there's no debating it. But you can't say something like, what's the set of all fun toys? That's not well defined. We could say, what's the set? Sorry, what's your name? Marcel? Okay. We can say, what's the set of all toys that Marcel thinks is fun on Monday? That's well defined. So this is just a little reminder that there is a certain amount of mathematical or logical precision here. We're going to be seeing more and more of that as we go. Okay. So we're just talking about how do we write down a set. Well, there's a couple different ways to write down a set. So one way is to simply say Jimmy's toys. So that's words or a description. We can also write down a list. Xbox, crayons, blah, blah, blah. Now there's this other fancy sort of looking notation, which is called set builder notation. And it looks like this. Now there's some extra stuff in here. Let me explain to you what this says. This says X such that X is one of Jimmy's toys. So it may seem like there are a couple extra there's a couple extra words and a little extra notation in there, more than you need, and for our purposes there probably is. I'll just say that there's a level of rigor here that you need when you do slightly more advanced mathematics. But that's set builder notation. So now let's get used to using these notations. Whoa. All right. So let's describe this set in different notations. So in words, the set is positive even numbers. So now how would we write this down as a list? 2, 4, 6, 8 is 0 positive? Is 0 positive? 0, it's not undefined, it's neither positive nor negative. Okay. So, first of all, so you would write down 2, 4, 6, 8. What else would you have to write down? Right, okay. So, obviously, you wouldn't be able to literally write down every single positive even number. So, how do we get around that? That's the next one. If we're writing down a list, how do we write down, and it keeps going forever? ... There you go. Now, if you're writing down a set, what else is missing that you didn't tell me yet? Brackets. Okay. And finally, we can write this down in set builder notation. How would you write this down in set builder notation? Not all positive numbers. X such that X is a positive even number. With the brackets. Okay. Here's another set. T equals 3, 6, 9, 12, 15, 18, ... How would you describe this set in words? Right. Not just multiples of 3. There's more. Positive multiples of 3. Right. Now, answer me this. Yes or no? Absolutely. Okay. No, it's not. And how do we write that? Yeah. Right. Only it's not equals. What does the little e say? Right. There you go. Okay. So consider this set A, which is 6, 12, and 15. How can you compare A and T? Everything in A is divisible by 3, right. So now let's think about the set A and the set T. How can you compare those two sets? Absolutely. And how do you write that? Right. So don't need brackets. You only need, in this case, we're talking about A and we're talking about T. It's already a set. Use brackets when you're defining when you're making a list of what elements are in a set, which we're not doing right now. We already know what the set is. We're just talking about A and T as they are. A is contained in T, or A is a subset of T. because everything in A is also in T. All right, in particular, I want to point out a distinction here. Notice the difference between using the little e for is an element of and using C for is contained in. In this case, when we use the little e, what kind of thing is 5? It's a single item or a single element. And over here, A is a set. So notice that in the first statement, in the first question, we're making a comparison between an element and a set. And in the second one, making a comparison between a set and a set. And in terms of set theory, these are two very, very different statements. This is element and set, and this is set and set. Okay.
These things you're writing are going to be in the lecture.
They absolutely will be. Yep. Okay. So all odd integers. How do you write that as a list? Okay. We've got 1, 3, 5, 7, dot, dot, dot. So is that good? He's half right. Yeah. There are also, these are integers that are also negative numbers. So how are we going to write that in? Excellent. There you go. So integers are tricky because notice that it goes on forever in both directions. Negative numbers. Okay. So, and just a little comment. What about if you just wrote down ... 7, 9, 11 ... Well, yes and no. This is correct, but the other way is more helpful because it reminds us that the set includes negative numbers. So remember that when you write ... and we're going to talk more about this later in the course, when you write ... you're saying, and the pattern continues forever. Notice that in the first case, it's much more clear what the pattern is. The first case says the negative numbers continue forever and the positive numbers continue forever. In the second case, you'd sort of have to figure that out. It's not exactly obvious. Okay. One more bit. N of A is the number of elements in the set A. N stands for number. Okay. So here's the set A, 1, 3, 5, 7. What is N of A? Yes. What is the number of elements in the set A? Right, y'all? Is it infinite? Right. 4 elements. Okay. Any questions for what we did so far? Any questions? Yep. Any questions? No? Okay. All right. Question? No? Okay. That's it for today.